Hi dear students, welcome to this session. I am your Bala sir. Last class we have discussed what are the different types of charges and what are the basic properties of the charges. These things we have discussed in the previous session. In this session we are going to discuss very important topic called Coulomb's Law. This will be very important concept for you, not only for your board examination and also for IIT JEE as well as NEET examinations. Right, let's go to the content. What is Coulomb's law? Actually, when we have two charges, namely positive charges or negative charges, what will be the interaction between the two charges? There will be repulsion or attraction, depends on the type of charges. When we have like charges, positive and positive, there will be repulsive. When we have unlike charges, positive and negative, there will be attractive force in nature. Okay. What is the magnitude of the force between the two charges, that we have to know, and this magnitude of the force can be understood from the Coulomb's law. That is what we are going to discuss first. Yes, are you ready? Yes. This Coulomb's law states that the force of attraction or repulsion between the two charges is directly proportional to the product of the charges and inversely proportional to the square of distance between the 2 point charges. Here you have to note this magnitude of the two charges. Okay, that we have to consider. Doesn't matter whether it is positive or negative, we are going to consider only the magnitude of the two charges. When we have two charges, namely q1 and q2, separated by a distance, there will be a force. If it is both charges positive, then there will be repulsive force. If they are negative, then there will be attractive force. And the nature of the force is always directed along the line joining the two charges. That is very important point. It acts along the line joining the two charges. Right? Okay, you got this right? Okay. So there is a force between the two charges and its magnitude is directly proportional to the magnitude of the product of the charges and inversely proportional to square of the distance between the two charges. Okay. What naturally we understand from this statement? Okay. Whenever you increase the charge, the force also will increase. When you decrease the magnitude of the charge, the force will decrease. And let's come to the distance. Distance here inversely proportional to square of the distance actually. So when you bring the charges close to each other, the force will go on increasing. When you separate the two charges, the force will gradually decrease. Right? So the mathematical expression, right? Force F is equal to constant K Q1 Q2 divided by R square. K is K into Q1 Q2 upon R square, right? So if you remove the K, you can make proportion. F is proportional to Q1 Q2 upon R square. Yes. Okay, now we are going to see the about the constant, and also we are going to what is 1 Coulomb charge. Here 1 Coulomb charge, generally the unit of the charge is Coulomb, and 1 Coulomb, how it is defined. 1 Coulomb charge is defined as the force which when placed two unit charges with 1 meter distance separation experiences force 9 into 10 to the power of 9 Newton. Right? You have two charges Q1, Q2 and keep them as unit charges and keep the distance between the two charges is 1 meter. If they experience this magnitude of the charge 9 into 10 to the power of 9 Newton, then you have the charge 1 Coulomb in space. That is the definition for 1 Coulomb charge. Here the explanation, Q1 is equal to Q2 and keep the values are 1 Coulomb and also keep the distance R is equal to 1 meter. So what will happen? We have already seen that F is equal to K Q1 Q2 by R square. Here Q1 equal to 1, Q2 is equal to 1 and R is also 1. So F automatically is equal to constant K. And now let us discuss about this constant. This constant K is given as 1 upon 4 pi epsilon 0. Okay. This epsilon 0 is nothing but permittivity in free space. What is permittivity? It is nature of the medium. How much field produced by the charge is allowed by the medium. That is called the permittivity of the free space. I will explain in detail later. Okay, its numerical value, epsilon 0 value is 8.85 into 10 to the power of minus 12 Coulomb square Newton inverse meter to the power of minus 2. How this unit comes? We know that F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R square. Therefore, what is our epsilon naught? Q1 Q2 divided by FR square. So, Coulomb into Coulomb, Coulomb square divided by Newton meter square. So, when you bring the Newton meter square to the numerator, you will get Newton power minus 1, meter power minus 2 and Coulomb square. That is the unit for this. Okay. Now, if you substitute Q1 equal to 1, Q2 is equal to 1, R is equal to 1, then automatically F becomes K, which is equal to 1 divided by 4 pi epsilon naught. And if you substitute the value of epsilon naught, you will get this value 9 into 10 to the power of 9 Newton. So that is the important term for us. Okay, important quantity for us. Now let's express the Coulomb's law in vector form. Okay, that is, we know that the force is a vector quantity. So we can also express the force, I mean the Coulomb's force in vector form. Right, you have the two charges here. Q1 is here at a distance R1, it's a position vector from origin O, and Q2 is the another charge, its position vector is R2 vector, and the displacement here, suppose when the charge or the distance between the two charges is here R21, that is R2 minus R1. R21 means, what does it mean? The force acting on Q2 by Q1, and also the force is acting towards the charge 2 from 1. That is what the R21 represents. Here the expression is given as Q1 is here, Q2 is here. This is the force F21, which is nothing but force acting on the charge Q2, right? The force acting on the charge Q2 by Q1 is represented as F21. The direction of the force is towards 2 from 1, that is represented by the unit vector R21 cap. So this is for the Q1 Q2 greater than 0 for the positive quantity. In the case of negative quantity, if Q1 and Q2 is product of the two charges is lesser than 1, the force is directed in the opposite direction. So here there will be repulsive force, and here we have attractive force. Yeah, this charge Q1 is attracted by Q2 and Q2 is attracted by Q1. Suppose if you want to express F12, what does it mean? The force is acting on Q1 by Q2. The direction also you can write as R12 by unit vector. Okay. How to express the force? Force on charge Q2 by Q1. Okay. Force is acting on Q2 by Q1 is represented by F21 vector. Am I right? F21 vector is the first two number is denoted by force is acting on the second charge by the first charge. What is our second charge? Q2. What is our first charge? Q1. So force is acting on Q2 by Q1, which is represented by 1 upon 4 pi epsilon naught Q1 Q2 divided by R21 square into R21 cap. If you multiply this numerical value by this unit vector, you will get the vector representation. If any number is multiplied by the corresponding unit vector, it becomes vector. That is what we have written. Here the R21 is the direction of the force is acting towards 2 from 1. That is the point you have to note. Got it, students? Good. Fine. Then R21 cap is the direction of force along the line joining the two charges. Already we have told that force is always acting between the two charges in the line joining the two charges from Q1 to Q2. Next, suppose if you are interested to find out the charge on force on charge Q1 by Q2, and this can be written as F12 vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 R12 square R12 cap. So what is the difference between the two expressions? Here the force is acting on the charge 2. So it is represented as R21 vector. The force is towards the charge 2, Q2. But here the force acting on the charge Q1 by Q2 is represented by F12 vector, which is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R12 square R12 cap. Here the R12 cap is the direction of the force is acting towards the charge Q1 from Q2. That is the point you have to carefully note down here. So R12 cap is the direction of the force along the line joining the two charges from Q2 to Q1. There Q1 to Q1 to Q1, Q2, and here Q2 to Q1. That is the point you have to note. And one more thing, when the direction is reversed, there will be negative sign, right? So R12 vector, R12 cap is equal to negative of R21 cap. When you substitute this quantity R in the place of R12 cap, if you substitute minus R21 cap, which is nothing but minus F21 vector. So F12 vector is equal to minus F21 vector, which is in agreement with the Newton's third law. Am I right? You got it? Is it clear? Okay, thank you. Next we will discuss what will happen when we have number of charges. So far we have discussed only with the help of two charges, what is the force acting between the two charges and what are the direction of the forces. But here we are going to see the system of charges. When we have more number of charges, what will be the resultant force? That we can understand from the superposition principle, right? Superposition principle is very helpful to calculate the total force acting on a particular charge due to many other charges in the system. To find the total force acting on a charged particle due to many other charged particles in the system can be determined by this principle. Okay, this is very important principle also. Here we have two charges Q2, Q3 charges, Q1, Q2 and Q3. We have three charges and they have respective positions R1, R2, R3 from the origin. Okay, so there will be a force between Q1 and Q2, Q1 and Q3, right? So the force between Q1 and Q2 is represented by F12 vector. So what is F12 vector? Force on the charge Q1 by Q2. Similarly, the force between the Q3 and Q1 vector is represented as F13 vector, is acting along the line joining the two charges. That is represented by F13 vector. So here F13 means what? The force acting on the charge Q1 by Q3. And now we have the two forces F13 and F12. To find the resultant, we can use the parallelogram law. So F1 is the net force for us to calculate the resultant force for these two forces. Am I right? Yes. Now, when we have more number of charges, we can calculate the net force using the superposition principle. So, as we have seen in the diagram, the force acting on Q1 by Q2 is given by, already we have discussed this, F12 vector is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R12 square into R12 cap. Similarly, force acting on Q1 by Q3 is given by, yes, because we have three charges. So total force acting on the Q1 only we are going to find. Yes, F13 vector is nothing but what? Force on Q1 by Q3. Yes, it is given by 1 upon 4 pi epsilon naught Q1 Q2 by R13 square into R13 cap. This R12 and R13 are simply the directions, unit vectors. The total force acting on the charge Q1 can be mathematically expressed as F1 vector is equal to F12 vector plus F13 vector. Simply you can add them and that will be equal to simply added 1 upon 4 pi epsilon naught Q1 Q12 by R12 square R12 cap plus 1 upon 4 pi epsilon naught Q1 Q3 here actually. So there is a small correction, you have to make correction here. This one Q1 Q3, here also Q1 Q3 by R13 square R13 cap. So students, please make correction here. This is in the place of Q2 you have to write Q3, here also Q3. Sorry for this. Then when we have more than 3 charges, we can generalize according to the superposition principle. F1 vector is equal to, we may have n number of charges in the system. All the charges can exert force on the charge Q1, and the net charge can be found using the superposition principle. F12 vector plus F13 vector plus F14 vector plus etc. plus F1n vector, and this can be written as F1 vector is equal to, if you add all those and you will write the 1 upon 4 pi epsilon naught is a common term, you can take it away, then you can add all the remaining terms. So what is this quantity? This quantity is the force acting on the charge Q1 by Q2. This is the force acting on the charge Q1 by Q3, and this is the force acting on the charge Q1 by Q4, and this is the force acting on the charge Q1 by Qn. You may have any number of charges, and in the system you can calculate the net charge acting on the charge Q1 with the help of the superposition principle, and mathematically this can be simplified or rewritten as, here in every term we have Q1, so you can take Q1 also common, so Q1 divided by 4 pi epsilon naught sum over I is equal to 2 n. So when you substitute I is equal, because already we have Q1 here, if you substitute I is equal to 2, you will get a Q1 Q2. So already Q1 here, Q2 is here, so you will get Q1 Q2 by R12 square. If you substitute I is equal to 3, you will get the second term Q1 Q3 by R13 square, R13 cap. If you substitute I is equal to 4, you will get Q1 Q4 divided by R14 square, R14 cap, with the constant 1 upon 4 pi epsilon 0. So this is the generalized formula, generalized expression to find the total force acting on a charge in the system due to many other charges in the system. Okay students, so with this we have the discussion in this session. So we will discuss the electric field in the next session. Keep watching, keep subscribing the channel Wisdom in Physics, and share to your students. If you are satisfied, if you like, put like and comment. If you have any suggestions, please post in comment box. I will update this. Keep watching. Thank you for your watching this video. Thank you.